Hi, my name is Shailen, and in this webinar we'll be talking about SharePoint timer jobs. So, a little bit about timer jobs. What are timer jobs? They perform much of the existing backend work to maintain a SharePoint farm, and they can run on one or more servers at a scheduled time, and they can run periodically and independent of users. They can also be load balanced. And what are they suitable for? So they're suitable for running long-running processes and offloading it from the web front-end server. They're useful for running code under high privileges, and it's basically the hammer approach or the extreme approach to solving a problem. So do use it as the last resort. Some examples of timer jobs in SharePoint are the user profile sync service, the solution deployment service, the search indexing, cleaning up the old site service, etc. To get to a timer job in SharePoint, you'd go to Central Administration, Monitoring, and then review the job definitions. So how do timer jobs run? Well, essentially timer jobs run via a Windows service called OWS timer.exe. That Windows service is called SharePoint Timer Services in the Services console panel. Let's talk about the architecture of a SharePoint timer job. In simplest terms, a timer job is a class which implements the SP job definition class. That class has four parameters, the first one being the name, the service, the web application, the server, and the log type. Now, the service is basically an instance of the SP service class which owns this job. The web application is the parent web application instance for that timer job. The server is basically an instance of the SP server class, and the log type determines the circumstances under which multiple instances of the job can run. Let's talk about the SP job log type values. A value of none means there are no logs, and the timer job runs on every machine. A log type of content database means that the job runs for each content database associated with the job's web application. If it's of a log type job, then only one server can run the job at a time. Let's talk about the architecture of a timer job. A timer job is a class which implements the SP job definition class. You'd override the execute method and provide your own business logic in there. In the execute method, you're provided a target instance ID variable which maps to the GUID of the current content database while the timer job is running. When developing a timer job, here are the basic steps. Number one, you'd create the timer job class. Number two, you'd create the timer job settings class. Number three, you'd write your business logic, preferably in a separate assembly. Number four, you'd write a SharePoint feature to install and uninstall the timer job. Number five, you'd provide a utility to update the timer job settings as part of the installation.
Let's go ahead and build a code sample. First, we'll start Visual Studio in admin mode. We'll select the empty project template and choose a farm deployment configuration. Next, we'll add a folder where we'll add our timer job class. Let's call it timer jobs. And then add a class for the timer job. We'll add another class for the timer job settings. This will store the configuration values for the timer job, like your database connection string or a web service URL. You can delete the timer job body and insert the snippet supplied with this presentation. You can install the snippet designer from Codeplex. Next, we'll add the snippet for the timer job configuration class. As you can see, this class has a property called property1, which will be supplied to the timer job at runtime. That property value will live in the web applications property bag. Lastly, we'll just add a utility class for logging. The code snippet for the utility class will log to the SharePoint ULS log. The code should compile now. Next, we'll add the business logic assembly. Start by creating a new project based on the class library template. We'll add a class for the business logic. And insert the snippet of code for this business logic class. This piece of code exposes the class as a singleton instance with an execute method where we'll put our custom business logic later on. It is a good idea to have your business logic in an external assembly so that you can unit test it via a console application. Towards the end of this presentation, we'll actually go ahead and debug the timer job in real time as well. So we're changing the assembly's platform target to a 64-bit version, and we'll leverage the same strong name key from the timer job project. Now we'll add a feature to install and uninstall the timer job. Start by right-clicking on your timer job project and select Add Feature. Let's rename the feature. We'll give it a title and a description as well. And then we'll change the scope to a web application scope. Now we need to add an event receiver to the feature. And then we can get rid of the body and insert our own code snippet. This snippet will elegantly install and also uninstall the timer job when the feature is installed or uninstalled. It will also set up the configuration for the SharePoint timer job and give it a default value. Finally, we will create a helper assembly which will aid in deploying and installing configuration for the timer job. We'll start off by creating a console application. We can then replace the main method with our own body after we add a reference to the timer job assembly and the SharePoint DLL. What the code snippet does is that it takes an input with either a get or a set method, and when it does a set, it will take a property value and save it in the web application's property bag for the timer job. And in the get operation, it will simply display the value of the saved property. We'll also add a helper class to the same project. Once the project compiles, we'll go into its properties and set it to a 64-bit platform. And then we can test it. So we'll open the project in Explorer and find its executable path, copy it to a command window, and try and invoke the exe without any arguments. This will display the usage. Then we can try to do a get operation to display the value of the property we created for the timer job called property1. Since the timer job hasn't been deployed yet, we should get nothing back. Now let's go ahead and deploy the timer job. Doing this via Visual Studio will also activate the feature. Now remember, the feature has an event receiver that will set a default configuration value for the timer job, and when we do a get against it now, we should see the default value for property 1. We can also set a new value for property 1 and then do another get to see the new value. Finally, let's look at debugging the final solution. First, we'll locate the MyTimerJob project and then its package. Click on Advanced and add the output of the business logic assembly. This is so that the business logic assembly gets deployed with the MyTimerJob feature. Once done, we can right-click on the project and deploy it to SharePoint. This will also install and activate the feature. To view the feature, we can click on the Application Management tab and then click on Manage Web Applications. Click on the web application and click on Manage Features. We should see our feature in there marked as active. To locate the timer job, we'd click on Monitoring, review job definitions under timer jobs, and then scroll down to locate our timer job. As you can see, the timer job has been installed with the default schedule from the event handler of the timer job feature. You might also want to look at useful debugging PowerShell.txt for some useful scripts when debugging timer jobs. The first one is restart service sptimer v4, which is very useful when you're redeploying timer jobs, as it makes sure the new DLLs are loaded in the timer service. Now we can simply click on the timer job class and add a breakpoint. Then we'll click on debug, attach to process, and make sure that the show processes from all users is ticked, and then locate owstimer.exe and click on attach. Once attached, we can go back to the useful debugging PowerShell.txt and copy the next line, which locates the timer job via PowerShell. And then we can start the timer job reference. We could also do the same thing from the central admin monitoring window. In a short while, we should see the debugger firing, and when stepping down, we should also see the default value of the timer job setting. As you can see, property 1 is set to default value, and that value is then passed on to the business logic layer. Now, what we'll do is we'll go to this timer job settings helper directory and locate the executable and try and retrieve the default property value for the timer job, which is set to default value. Then we can try setting it to a new value. The new value gets saved to the property bag of the web application for the timer job. When we next hit the debug again, we should see the new property value come back. Another useful way of debugging is using the provided ULS logger. To view messages in the ULS log, you'd open the most recent log file. And then edit the filter to filter on the category for the timer job demo. You should see all the log statements that were generated from the timer job itself. Thanks for watching, and please be sure to pass your feedback on to me via Twitter or LinkedIn.